Problem number 11 is asking us to prove the following identity. And really what proving an identity means is that we want the same thing on the left side as we have on the right side of the equation. And for this, I like to start by manipulating only one side. So I'm going to stick to manipulating the left side of the equation. My favorite place to start with these types of problems is substituting in something for cotangent and tangent, because that can usually be a great place to start seeing where things are going to simplify. So I'm going to substitute in cosine theta over sine theta for cotangent, and sine theta over cosine theta for tangent. Now I know fractions are gross, but I do want to add them, and in order for that to happen, I need to have a common denominator. So I'm going to make my common denominator sine times cosine. So I'm going to multiply this first fraction by cosine and the second fraction by sine. So that gives me sine theta times cosine squared theta over sine theta cosine theta plus sine squared theta over cosine theta sine theta equals secant theta. So then I can actually add that fraction and get cosine squared theta plus sine squared theta over sine theta cosine theta equals secant theta. And then I can use the Pythagorean identity to substitute in 1 for cosine squared theta plus sine squared theta, because I know that cosine squared theta plus sine squared theta equals 1 from my resources. Still over sine theta cosine theta equals secant theta. Multiplying by sine theta causes the sine thetas to cancel out, and I get 1 over cosine theta equals secant theta. And then using my resources, 1 over cosine theta is secant theta, so I get secant theta equals secant theta, and my identity is proven.